Hi everyone, it's Coach Fred here, and today I'm going to be doing a video of the lesson that we did in class. So today we're going to be solving linear equations, and so you're going to be able to, number one, tell the difference between an expression, which we've been talking about, and an equation. You're going to learn how to solve one and two step linear equations and justify your steps. And you're going to be able to tell if something has one solution, no solutions, or it could have infinitely many solutions. So that's our goals today. Now, at the beginning of class, I asked you to go through and basically tell me what you already know. I'm not going to do that in this video. And then I also asked you to answer some questions in your own words. That's me trying to figure out what you already know about the topic. So we're going to actually start here. I want to make sure we know the difference between an expression and equation. So when I think of an expression, the first thing I want to think about is that it's like a math sentence, right? It is a math sentence. It does not have an equal sign, so no equal sign. It can be made up of numbers and variables. It could look like 2x, that's an expression. X plus 1, that's an expression. 3x plus 5, that's an expression. And why is that important? Well, because if it's an expression, we have to understand what we do to expressions. The only thing that you can do to an expression is simplify it or evaluate it. And you have to use proper order of operations to do that. So expression, if you see an expression and the directions really aren't clear to you, you have to say, these are the only things I can do with it. So simplify. Whereas an equation is different. Equation's a math sentence as well, but an equation has an equal sign. It has an equal sign. And for now, I want us to think of equations having one variable. For now, okay? I think it's going to be easier if we think about it like that. So equations have one variable, has an equal sign. It really is made up of an expression equaling an expression. And since you do know what to do with expressions, on the left side you're going to simplify, on the right side you're going to simplify, and then you're going to solve, which is different. So when it has an equal sign, we're going to solve it. And that's what we're going to be talking about today. And I think it's really important for us to know that when we solve it, what you're doing to solve is you're really trying to find the variable that makes the sentence true. That makes the sentence true. The math sentence true. Yeah, math has sentences. Can you believe it? All right, so here's an example. I say to you that the domain of x, that means the inputs I want you to try for x, okay, are 1, 2, and 3. It's saying, is the equation 5x minus 1 equal to 9 when x is 1, x is 2, or x is 3? So we're going to test it out. We're going to try it with x equals 1. So I'm going to take 1, I'm going to substitute it in, and see if it makes the math sentence true. Well, 5 times 1 is 5, 5 minus 1 is 4, 4 does not equal 9, so that is not making the math sentence true. All right, let's try 2. 5 times 2 minus 1 equals 9. That gives me 10 minus 1 equals 9. So 10 minus 1 is 9. 9 does equal 9, so I know that that is a solution to my equation. All right, because it makes the math sentence true. I'm going to try 3. 5 times 3 minus 1 equals 9. 5 times 3 is 15. 5 minus 1 is 14. 14 does not equal 9, so the only solution to this equation is x equals 2. That's basically what you're doing when you solve an equation. But now let's move on. Let's talk about solving. In order to solve a linear equation, because that's what we're working right now, is just linear equations, we have to use inverse operations. So we really need to know what an inverse operation is, okay? I call it the undoing operation. What I mean by that is I'm always trying to get back to where I started. So here's what I mean. If I said to you, I gave you the expression x plus 2, what is happening to x? Well, I hope you're seeing that 2 is being added to x. So if I was trying to get myself all the way back to x, to get rid of the 2, I'd have to do its inverse operation. The inverse of addition is subtraction. So if I subtract 2 from the expression, they go away and I'm left with x. So that's the undoing piece I mean. If I gave you 2x, well, what is happening to the x? What is 2 doing to the x? Well, we know that there's a hidden multiplication sign right there, so it's being multiplied. So if I want to get back to x and get rid of the 2, I'd have to divide by 2. I'd have to use the inverse operation, and they would simplify to 1, and I'd get back to x. So the inverse of addition is subtraction, and vice versa. The inverse of multiplication is division, and vice versa. And for some equations, the ones we're going to start with, if I give you a fraction, the inverse is going to be a reciprocal. And we're going to talk about that a little bit more because that's not actually true, but I'm going to help you use that a little bit better. All right, so here's what I mean. I have all types of equations that we're going to be working on today. Our first goal would always be to simplify each expression, so meaning each side. So each side of the equals. So on this side, I have 6 plus x. I can't do anything with them because they are not like terms. On the other side, I have 11. So it's simplified. Not much more I can do. Then the goal is to isolate the variable. That means you have to get x alone. So this is where we have to use inverse operations. So you have to say to yourself, what is this 6 doing to x? Now in this particular example, I don't think it is all that easy to see what 6 is doing, right? So I actually like to use the commutative property and rewrite it as x plus 6. I always like to put the variable first if I can. It helps me. All right, so now I can see that 6 is being added to x. So to get it to the other sides, we call balancing the equation. We have to use the inverse operation. So I would have to subtract 6 from both sides because whatever you do to one side, you have to do to the other. That gives me x equals 5. So what was the inverse operation that we used? Subtraction. What does my answer mean? That's important. I want us to get into a habit of understanding this. My answer, so 5, is the value that makes the equation true. Makes the equation true. All right, let's try another. So I look at it, I simplify each side of the expression of the equation if I can. I can't because there's no like terms. So I'm ready to solve by using the inverse operation. So I have to isolate the variable. So I have to get the 3 to the other side. So you can see that 3 is being subtracted from x. So to get it to the opposite side, I would need to add it to both sides. Whatever you do to one side, you have to do to the other. So you can see Coach Fred likes to put a line because then I can see that these simplify to 0. I'm left with x, and then I do 1 plus 3, which is 4. So what was the inverse operation I used? It was addition. Okay, what does 4 mean? 4 is the value that makes the equation true. And that's important because if I can't solve it, I might try values. I might just try different answers and see if they work. All right, let's make it a little different. How is this different? This one's different because now I need to point out we actually have a sign in front of the x, and it's a negative sign. So one way to think about this is, again, rewrite it using the commutative property where the x is in front. So that negative would actually have to come with it. And I have to remember there's a hidden plus sign in front of that 6, a hidden sign in front of the 6. But I find it easier when the variable is first. All right, so now I have to isolate the variable. So I see that 6 is being added to x, so I would subtract it from both sides. Now, unfortunately, that leaves me with a negative x. And negative x is not what you're solving for. You're always solving for a positive variable. 3 minus 6 gave me negative 3. So how do I get rid of that negative x? Well, I need to know that there's actually a 1, a hidden 1 in front of it, negative 1. So what is negative 1 doing to the x? I hope you see that it's multiplying. Okay, so because it's multiplying, I need to do the inverse operation of multiplication, which is division. So I would have to divide both sides by -1. Tricky, right? All right, now I have a -3 divided by a -1, which is going to give me a +3. So what was my inverse operation? It was first subtraction and second division, because that's a multi-step equation. Okay? What does 3 mean? 3 means that if I plug it in, let's try it. 6 minus 3, does it equal 3? 3 equals 3. It makes the statement true. All right, let's try that division again. Here I have -5x equals -10. I can't simplify anything on each side. They're already done. So now I have to use inverse operations. I need to remember that that -5 is actually being multiplied to the x. There's a hidden dot there, meaning multiplication. So the inverse of multiplication would be division. So I would divide both sides by -5. Whatever I do to one side, I have to do to the other. So I do -10 divided by -5, which gives me 2. So what was my inverse operation? It was division. What does 2 mean? It means that it's going to be the value that makes it true. So -5 times 2 should equal -10, and it does. A couple more. 4x equals 0. Now this is tricky. Coach Fred's trying to trick you here, but not really. 4 is being multiplied to x, okay? So I have to do the inverse operation, and I divide by 4 on both sides. The question is, do you know what this means? What does this mean? And it's tricky. When you have 0 in the numerator, 0 divided by 4 is 0. 4 doesn't go into 0. It goes in no times. So when 0's in the numerator, that's what it means, 0. And we're going to talk about that. There's a really crazy thing that can happen if 0's in the denominator. So we don't want 0 in the denominator for now. So what was the inverse operation? We divided by, it was division. So in this case, we divided by 4. All right, another tricky one. X over 2 equals 1/2. Okay. I need you to recognize that what this really means is 1/2 of x, because there's a hidden 1 here. Does that make sense? When we have a fraction being multiplied to a variable, I need you to recognize that variable always goes in the numerator to the top. All right. So now this is an example of where I said we need to know what a reciprocal is. So a reciprocal just means a flip of the number. So if I gave you the number 2/3, the reciprocal would be 3/2. If I give you the number 1/2, its reciprocal would be 2/1. If I gave you a whole number, 4, helps to put it over 1 because its reciprocal would be 1/4. All right, so that's helpful information for us. So I have 1/2 x equals 2. Again, 1/2 is being multiplied to x, so you would normally divide. But a trick here is if you divide by 1/2, that gets really tricky looking. And you have to remember that you'd have to keep, change, flip, and you might not. And so you may, and that's totally fine to do. You just have to remember you'd have to do 2 times, keep 2, change from division to multiplication, and flip the denominator. Or another way of thinking about this is if you have a fraction in an equation multiplied, and it's only one fraction, and so you have one expression and one expression, multiply both sides by the reciprocal of the value. So 1/2, its reciprocal would be 2/1. So you're kind of skipping a step, but it works because the 2's will simplify to 1. So you're left with x, and then I just have 2 times 2, which is 4. So what was the operation you used here? You multiplied. Oops, I spelled that wrong. Multiplied by the reciprocal. Multiplied by the reciprocal. Okay, let's put a multi-step together. We're going to stop on these two, okay? So I look at it. Now, we have to simplify each side if we can, and if we can't, we go to solve. Now, the thing about solving an equation that's different than GEMDAS is we're actually doing backwards GEMDAS. So I want you to think about GEMDAS is for expressions, and we go this way. Solving, we use backwards GEMDAS because we're going in the opposite direction. So addition and subtraction has to come first. All right, so I see that 4 is being subtracted from 3x. So that means I have to do its inverse. So I have to add 4 to both sides. Line, 11 plus 4 equals 15. And so now I have a simplified equation. Then I move on to multiplication and division. So I see that 3 is being multiplied to x. So I have to divide both sides by 3. That will leave me x equals 5. So my inverse operations were addition and then division. And again, if I plug 5 in, it is going to make the equation true, or it should. And if it doesn't, then you made a mistake in your calculations. So 15 minus 4, does it equal 11? And it does equal 11. All right, last one. I know this is kind of long. All right, so again, I've got to use backwards GEMDAS when I'm solving an equation. So that means I have to do the addition and subtraction first to get it to the other side. So I'm going to add 5. That gives me 18 equals 6d. Now I'm not using x this time. I'm using a different variable. That's okay. 6 is being multiplied to d, so I'm going to divide by d, giving me 3 equals d. Again, what did you do? You used addition and division. And 3 is going to make the equation a true statement. All right, I'm going to stop there, but hopefully that was helpful. In class, we probably got a little bit farther, so you might want to keep trying those problems. Have a great day.